Hello everyone and welcome to this demo video. Today we're going to be talking about the Payflux platform, which is simply an interoperable assets payments platform using one simple payment API for assets across chain. So let's say a customer pays with XRP on XRPL, Flare's data connector independently verifies it. The merchant is settled in FXRP on Costin2. So we have one simple integration, no chain specific code. So XRPL is our source chain, FDC for our verification layer. That's Flare's data connector, and then settlement is in Flare assets, and then record of truth is stored on the Costin2 testnet. So let's go straight into about what this website does and all of that. So in this section here, you can see this is our implementation. You can see how the code is used and whenever a function is called. Let's say this is a post request. You can see that the user is, sending this intent with just $50. This is what the user understands, but it's being paid in the available assets that are available via the merchant. And you can see the currency that was mentioned to be used as the payment, which is FXRP. So it is very straightforward. You can see what the SDK does and what it's all about. So it's simple, right? So a customer pays, Flare verifies and store the Costin2 records, and then the merchant settles. So for now, we don't have BTC and Dodge enabled on this. It's going to come later on. So just source assets on chain as it go. You can see our system architecture there, a little sample of how the flow works. So I'm just going to go straight into our docs. So this is our docs. So it's Payflux simply in one page, and what it does. So like the code sample that's being displayed on the landing page, so it's simply how this would work in TypeScript. And you can see, so in testnet only, so Payflux runs on the Flare Costin2 and XRPL testnet, so no mainnet moves for now. So this is how we use this platform, right? So you're going to sign in, you set your settlement address, create an API key and API keys and all of that. So so you can also check how your key works in our playground area. Moving on to our authentication, and you have on how our authentication credentials work, and how the keys are stored in SHA-256, which is digest and compared the keys in constant time. And this is how the keys look like. So you can see we have the SK, which is the secret key marker, the environment, which is our Costin2 testnet as shown in the key, and 32 random bytes, which should be at the end, and then the key ID. So the keys can be rotated at any single time you want. It just depends on the developer and what they want to rotate. So these are our scopes. These are the various scopes and interfaces that the payment API service works with. So write, read, settlement write, webhooks read, webhooks write. So these are all the grants that are associated with those interfaces. So moving on to like the errors that the scopes return when it's not being used properly. It shows all these in detail in our doc. So moving on to creating arguments, this is how an argument is created. So you can see that we have our order ID in here, and we have our metadata with our idempotency key. So this is our architecture in here, right? This is simply the flow, created, awaiting payments. The payment will be detected and verified by the FDC layer, then before being completely verified and settled. So this is our checking our routes section, shows how the various routes are used to redirect checkouts via the payment ID. Okay, moving on to our webhooks section. So these are endpoints in here, so we can simply, make use of the webhooks via our signing secret. So this shows you how it works and, how verification works with XRP approved by Flare, and how the FXRP and C2 FLR read directly from the transaction when it's sent, and how, a transfer is sent and tied to your order. So these docs just simply shows how everything works in this platform. I'm still going to go into that in detail. So this is our settlement layer, so FRXP, like I say, is not just a wrapper, so Payflux is not just a bolt conversion on the side of your payment, So it makes it mints the against the the customer's payments and all of that. So let's go back to our dashboard. Go back to our dashboard so you can see the whole glowing effect in the UI. So I'm going to sign in with my Google account. But before I do that, I'm just going to show you a quick overview of the various sections in here. So you can see the various sections that we have. We have our payments, verified, status volume, and then filled or expired, all our recent payments in our overview section. So moving on to our routes, you can see all the various payments, being used in our routes and payments area. Payments, you see all our payments. Go back to our routes section. You can see so these are the test nets that are currently supported by our websites, our payment API. So these are the routes that are being supported. Moving on to our settlements area. So you can see in the settlements area, we had a little error with one of the transactions when we were just trying this out. So it's still being recorded in there. And this is one that went through in there with the settlement layer. So moving on to our assets. So it simply shows the assets that are currently supported and are live on Payflux. So these are the assets that are live on Payflux here. So we have C2FRR, XRP, FXRP. So Dodge and BTC are going to come much later when this moves to our main nets. So moving on to our webhooks. So these are our webhooks. You have the option of simply defining your own webhooks, but for now, it just configured to the API that was used in developing this. So I'm just going to sign into my Google account. So it's going to prompt me to use one of my Google accounts to sign in as a developer in order to view and create API keys. Okay, we're in. So we want to create an API key. It's really simple. We have a lot of scopes in here for read, write, and all the interfaces that the API uses. These are the various calls. So we have our default keys that allows that we already created in here. So we can simply just rotate them anytime we want. So this example of how the rotation works, everything is in detail in here on the documentation of the API keys. So this is everything on it. Okay, so down here just shows how the key can be used with idempotency and all of that. So let's go back and just simply create an API key. So API key has been created. So we're just going to copy this. I'm going to use this to test whether it's working in our playground. So you see what the playground does, right? So it runs the read operation with the one write, right? So it just fires a single $50 payment intent, which is not going to be settled, but it's just going to fire it and to confirm that the key is working. So we can see there that the key is actually working. It's returning the right responses, the right response mechanisms. So this is our audit log. Just simply shows our activity on this account and what has been changed. And this is our diagnostics section. In here, we have all the capabilities of this, the Flare data connector, contract addresses that were deployed. Moving on to our settings section, we can simply, just modify anything we want in here because everything is set to defaults, to default wallets that I used in developing this. So another developer using this will have the option of being able to pre-configure their own signing secrets, your own endpoint URLs, and any type of settlement asset that they want to use that is supported by Payflux. So going back to our dashboard. Yeah, so in VS Code here, I want to simply show you how a transaction works with this. I'm going to fire a transaction from this script I have inside here. So this native.typescript script that we have inside here. Okay, what it actually does is it goes through a couple of stages, right? So in the various stages, we have stage 1, which fires the real price payment from the FTSO version 2 with no invented rate. So it awaits to get the feed price from the XRP against USD. Then it goes through an Flare assets reality check before setting up the registry on Costin 2. Then proceeding to the payments. So it's a very straightforward script. It simply just demonstrates the full capabilities of the API and how the SDK actually works. So on the other hand here, we have our Flare native provider. So this Flare native provider, the provider simply, shows our Flare integrations and how this works with the Payflux SDK once it's bundled. So you can see that I already fired a previous transaction here with all the evidence of, the payment registry, the intent, the payment ID, the XRPL transaction, the FDC intents, the voting rounds, and all of that. So going back to my GitHub, sorry, let me just go back to my GitHub. Okay, so in the GitHub repository of this web application or payment SDK API service, we have a simple npm run command in here that works with the native.ts script that I have in here. So what it does is it simply fires all these predefined methods in order to make, it just simply fires the API service. It fires the API service and all the interfaces that it works with to confirm that the Payflux API actually does what it's intended to. So I'm simply just running it, and you can see that it's running straight away. You can see that it's going through all we mentioned, the registry on costing 2, committing the intent on chain, and then, setting C costing 2, Flare, carrying the reference, verifying the transfer and all of that. So we're simply just going to wait for all of this to go through. You see all the transaction hashes are being sent and recorded on the custom 2 Explorer. It's also going to be recorded on the XRP Explorer and all. So just wait for this to go through in here. So we have our payment reference ID with our attestation. So now while we're waiting for this to go through, which is the voting, right? So I'm just going to simply go to the Explorer on XRP to confirm that this actually went through and this is not a superficial transaction. So you can see this went through, our payment was a success in here. So we're just going to go back to this. Okay, so while we're waiting for this to fire up, we're simply go to our Node.js package. I'm trying to navigate to what's there. All right, so we published the Payflux SDK package to Node Package Manager. So any developer just simply has to run the npm install command, and then this gets installed to your local code base, and you're able to call all the various interfaces that comes with Payflux. So inside our code section, you can see in our src and index.ts, you can see all our various payment types and interfaces that the Payflux API supports. It's a very straightforward interface, very detailed, and nothing superficial is in here. All live data on the various testnets that Payflux interacts with. CC has been published, and then the GitHub repo that is attached to it. Okay, so I'm just going to go back to my backend, which is hosted on Railway. As you can see, all our post get requests, the watcher and the index. So going back in here, you can see that this has been successfully completed. So both the verification mechanisms have been proven on costing 2. As you can see, the proof has been retrieved, tested amount 1 XRP, like I mentioned previously. And so you can see all the variables in here. The payment registry intent and all that has been secured successfully. So go back to my back end, you can see that as soon as the request was made, it also showed in our back end, which is live. So going back to our GitHub repo, this has everything you need to know about Payflux, how to use the SDK, the installation and everything. So I guess that is it for Payflux.